Good afternoon and welcome. This is just the briefing notes for the upcoming SAC for Mathematical Methods at Caroline Chisholm Catholic College. The SAC is going to be titled The Lighthouse, and it's positioned or it's centred on a lighthouse that's located in the middle of the Pacific Ocean with no other landmass around it. So we have a little image of this island and a boat passing by with just ocean to be seen across all of the horizons in all four directions. So we're just going to talk about each part of this SAC. So the first part, students are going to be presented with the concept of a lighthouse is located at the top of a cliff on a small island in the Pacific Ocean. The lantern room, that meaning the room where the light is generated or where the light emanates from, where the light comes out of, at the top of the lighthouse is circular, and the lantern rotates at a constant rate. So what we have here is a beam of light. Okay, this is our beam of light, and that will be rotating around the lantern room. And we need to account for the angle. And it will be rotating at a constant rate, as we have shown here. So the things that you want to consider is, firstly, how to model a circular function on real-world values. There'll be values that we will assign to the lantern room and to the beam and to the strength of its signal, and you need to be able to create a model or a function based on those values. And then once you've established that model, you need to be able to use it to find specific measurements that we're going to ask of you. So that's the first part. The second part entails a road runs north and south past the right-hand side of the lighthouse. The base of the lighthouse is set back from the road. The road is intermittently illuminated by the lighthouse's beam. So I'm just going to talk about this term, just to make sure that we're all understanding what intermittently illuminated means. It means at times the road will be lit up by the lighthouse, and at other times it will be in pitch black, okay, because the lighthouse will be away from it. So if we could think about, this is our lighthouse, and our road is going to be located here. Well, you know, the lighthouse could be moving from that point to that point, okay, at any stage. That means that the road is illuminated, it's lit up. So you're going to be asked to model a circular function based on this scenario. You're going to also be asked very particularly to write a domain of that function based on the real world experience. Okay, so have a good think about that. You need to write a domain where the light is hitting the road. That won't be all the time. And then you need to be able to use that model to find specific measurements. Okay, so we're going to ask what point is the beam hitting the road at certain times. So you need to be prepared for that. Then we move into part 3. And part 3 states this: light travels in straight lines. Since the Earth is curved, the straight line distance from an observer to the visible horizon increases with height. So what we're going to be asking here is to find what this distance is between the top of the lighthouse, which is here, and the horizon. Now, the lighthouse is going to have a height. The other thing that you need to appreciate is that the Earth is spherical, and therefore it has a radius. Okay? And when we join those together with the Earth curving like that, what we're actually creating is a right angle triangle. So we have a right angle triangle. Now that'll be the radius of the Earth. and then you'll have your distance, and then you'll have to use other values to be able to find what the distance is going to be. And you're going to be asked to model the distance between the top of the lighthouse and the horizon. Calculate the height of the lighthouse so it is visible from a specific distance. So if we're designing a lighthouse, we want to make sure that it's going to be visible. It might be for 30 kilometres, it might be for 50 kilometres, it might be for 60 kilometres, 100 kilometres. We want it to be visible from a specific distance. So we want to know how high we want to be able to build it. You're going to have to use some trigonometric ratios with this work. And another tip for you is that we're going to ask you to calculate the total surface area of the ocean that is illuminated by the lighthouse. Now that's not as easy as you think, because you're dealing with a sphere. Okay, so I'm going to try to draw a three-dimensional object. That's our sphere, yeah? And if we talk about the area that it's exposed to, well, the surface area is going to be curved and bended. Okay, so our tip for you is to research what a spherical cap is. Okay, get onto Wikipedia, get onto Google, get onto some even Wolf Math. You'll be able to research what a spherical cap is. It will help you greatly if you understand that. Then the last two parts of the SAC are going to be asking you to find specific areas using integral calculus. So you must remember that an area equals, your lower limit, upper limit, the integral of whatever function that you're dealing with. So you're going to have to consider the following. How do you find the area between two curves? What's the average value of a function using integration? So there's a rule for that. There's a rule for this that you have to get across. You have to also then be able to apply this information and be able to calculate a volume given both area and depth. Handy tip for you, know what the volume of a cylinder is. And then another further tip for you is to also consider what we term related rates of change. This you might need to research. Okay, so you might need to do some research on related rates of change, but that will be important. So other considerations for the whole task. So when we're considering the whole task, some other considerations that you need to take into account. The timing. We're running this on Ed Perfect. We understand we're all in lockdown, okay? But we've given you more than ample time to complete the task. So you have 2 hours and 15 minutes on Education Perfect. The task is going to start at 3:15 p.m. and will conclude at 5:30 p.m. Authentication. So at the last step of the assignment or the assessment will be for you to sign an authentication statement. Now you must sign this. It's really important that you do sign this. You need to note that if you do not sign this, then you will automatically be required to do a redemption task. Okay, so if you do not sign it, that equates to you doing a redemption task. The other important information which we always talk about is write your answers for every question on Education Perfect. So we understand that sometimes your solutions, okay, you might not write all the solutions out on Ed Perfect, that's fine, but you must have your answer there. And answer it correctly. If it says to 2 decimal places, then use 2 decimal places. If it says an exact value, then use an exact value. The other tip that I will give you, and I've said it a lot of times, and I know that Mr. Silva and Mr. Simeo have also reiterated this, be careful with units. You're in Year 12, you're doing Year 12 methods. You must get your unit conversions correct. That's all for now. Good luck, and I hope you do your very best on this task.